Hello everyone, I am Prabha Hirani, temporary lecturer in the Department of Software Engineering, and I am going to be your lecturer on this subject ETEC 11052 Introduction to Programming for Technology. Welcome you all to the subject. This course unit we will cover the basics about computer programming, which can be applied any and all programming languages that you might want to learn. After getting the knowledge about fundamentals, later we will move to the C programming. C programming is known as the mother of the all programming languages. I think it is the very simple and the best way to start to learn the programming languages. Those are the main things we are going to cover in this subject. And also we want to do some practical sessions in this subject with C programming. After Open the University, we will start the practicals. Now we will move to the today class, chapter 1, Programming Fundamentals. We will start from the simple question, what is programming, and we will mainly discuss about programming languages and how to develop a computer program in here in the first lecture. End of this lecture, you will get a basic understand what is programming and how to do it. What is programming? First we will see what is a computer. A computer is a general purpose machine which can perform many computational tasks. Modern computers can perform millions and trillions of computations in a fraction of a second. But they cannot do it in their own. Computers cannot think. If we want to do something in a computer, we have to give the instructions to the computer. These instructions will contain step-by-step process how to perform that specific task. Normally we are calling them as a program. And the person who writes the program or instructions we are called as programmer. Then let's see what is a computer program. A program is a collection of computing instructions or operations which are grouped together in a logical manner to accomplish a given task. It means if we want to do some task using computer, we have to give the step-by-step instructions, and if there are mathematical expressions, logical expressions, we have to give all needed things step by step. And there are mainly two types of programs. First one is system programs and second one is application programs. System programs are used to control the hardware resources. For example, operating systems like macOS, Linux, MS Windows and game engines like that. Then the second one is application programs. Application programs provide specific functions. For example, we can get Notepad to write a note and web browser, Adobe Reader to read a PDF or file like that. And we are using programming languages to write these programs or instructions. Programming languages. We are using a language like Sinhala, English or Tamil for communicate with each other. If we want to ask some person to do something for us, we can use a language that person can understand to give the instructions how to do it. Like that, programming languages allows human to communicate with the computers. We can define programming language as a combination of vocabulary and the set of grammatical rules for instructing a computer or computing device to perform a specific task. In the slides you can see some examples of programming languages: Java, C, C#, JavaScript, Python. Normally we are calling this as high level languages because these are human familiar than the machine familiar. We are using these high level languages to write the instructions to the computer. And basically there are three types of languages. First one is machine level languages, second one is assembly level languages, and the third one is high level languages. First we will see what are the machine level languages, or we can call it as binary languages. Machine level languages are computer familiar. Any computer can directly understand machine language defined by its own hardware architecture. It is consists of sequence of numbers with zeros and ones, only two values, zeros or ones. And computers are built to understand those patterns and they can work with it accordingly. But it is difficult to understand the machine level language by humans. There is an example in the slide, z equal x plus y. We can write it in the machine language like this, a sequence of zeros and ones. Now the problem with the machine language is the programmer should know everything. Everything means processor and the architecture of the computer to code with the zeros and ones, because it is directly working with the hardware and the memory. And also it is bit difficult to write and get the errors of 1000 lines of zeros and ones. To solve this problem, there are other type of programming languages. Then we are using next level is assembly languages. Instead of zeros and ones, in here symbolic or numeric codes are introduced. So they began to use English-like abbreviations to represent some elementary operations. Think you want to get the summation of two numbers 2 and 3. You just want to write the code add 2, 3 to add two numbers. If it is in the machine language, you should write several zeros and ones to get that code. Like that, there are so many codes available in the assembly language. This set of codes are human readable and it is easier to code than the machine language. But the computers cannot directly understand the assembly code. First, assembly codes need to translate it into the machine language. We are using translators to translate assembly language to the machine language. We are called it as assemblers. And also, if we are using assembly languages, again some issues are occurring. It is easier to code than the machine language, but it is but if the lines of codes are increasing, it is difficult to find the errors and fix. Assembly language also computer architecture dependent. Because of that, one code written in the one computer cannot executable in another computer which has architecture is different. To solve these problems, new languages are again invented. We call it as high-level languages. High-level languages are easy to code, easy to learn, and it is human familiar. High-level languages were developed to speed the programming process. Earlier also I mentioned some examples of high-level languages. In here also there are some examples: Java, C, C#, Python, all are high-level languages. And single statement can be written to accomplish multiple tasks in here. In here I give an example of C code. In here we can add 2 and 3, two numbers 2 and 3, and get the print the summation of that. And high-level languages allows programmers to write instructions almost similar to English language and common mathematical expressions. In here also the example is C code. It is print the hello world. It give the printout of hello world. And also again machines cannot read the high-level language codes because machines only read zeros and ones. So again we want to translate the program into the machine language code. There are two methods to execute the high-level codes. First one is compilation and the second one is interpretation. In the compilation it uses compilers, and the interpretation it is using interpreters. Interpreters and the compilers are very similar in the structure, but the main difference is that an interpreter can directly execute the instructions in the source programming, while compilers are translate those instructions into efficient code. Compiler takes entire high-level program at a time and translates it into the machine language, but interpreter takes a single line of code at a time and converts it to the machine language, then again get another line. And scripting languages are processed by interpreters. Scripting languages are the programming languages with a special runtime environments that automates the execution of a task. For example, I have given the two scripting languages, JavaScript and PHP. And this is a diagram of translation of languages. We are writing our code in the high level language, and using the compilers we can convert it in the assembly language, and again using the assemblers we can convert assembly language code to the machine language code. In here, assembly language and the machine language, we are called it as lower level languages. In lower level languages, programmers can easily access to the computer memory and work with the data. But in the high level languages, we cannot directly work with the memory and the data. Okay, now I think we have some basic knowledge about programming and the types of programming languages. In next, we will see basics about C programming language. C is a high-level programming language and it is developed by Dennis Ritchie at Bell Laboratories in 1972. This is a picture of Dennis Ritchie. C is based on two previous languages, BCPL and B. BCPL means Basic Combined Programming Language. It is not used in today. And B is also a programming language which invented early in the Bell Laboratories. C is very flexible and versatile, which allow maximum control with the minimal commands. So C is used to develop systems which require high performance. For example, operating systems like Unix and some parts of Windows, embedded systems like smartphones and robots, real-time systems like traffic controllers and the communication systems. Those are the basic things and the history of C program. We will discuss further in C programming in the later of this course. Now we will move to discuss about how to develop a computer program. What are the key points that we want to focus. In here I have given 7 steps. First one is define the program. Second one is outline the solution, then develop the outline into an algorithm. The next one is test the algorithm for correctness, and the fifth one is code the algorithm into a specific programming language. Sixth one is run the program on the computer, and the last one is documentation and the maintain of the program. Now we will see the first step, define the problem. If we got a problem to solve using a computer program, first we need to identify the input to the system. For example, think I have given 2 numbers to you and you have to get the total of the 2 numbers. Then what are the inputs? Inputs are the 2 numbers, number 1 and number 2. Then you have to identify the required output. What is the output we have to give it to the user? In the example, that is total, the summation of 2 inputs. And then you have to decide the process or step-by-step approach to get the output using the inputs. According to the example, first one is read 2 numbers, then you have to add that 2 numbers together as the second step, and the third step you have to print that total. We can use a diagram to represent above mentioned items like these. In here I have mentioned inputs as first number and the second number, and the output as total, and the processing, first one is read 2 numbers, then add 2 numbers together, and the third one is print the total numbers. We are calling this diagram as define diagrams. The step 2 is outline the solution. In here, we are further analyzing the problem and trying to identify the main task and the subtask we have to process, and also control structures, variables, record structures, line logics we have to identify. Later I will teach you what are the control structures, record structures, variables in detail to you. Now just get an idea how to and what are the things we need to focus when we are developing a solution. Then the step 3, develop an algorithm. What is an algorithm? Simply, an algorithm is a finite list of instructions most often used to solving problems or performing tasks. It refers to a detailed solution to the problem, and the solution is outlined in a manner in which the steps are clearly defined. In the first step, we identify the task that we want to perform to get the output. In here, we want to build a step-by-step procedure to get the output. And the algorithm defines the basic design of the computer program. Algorithms can be defined by pseudocodes or flowcharts. In here, you can see a pseudocode in the left side. It is for adding two numbers. Pseudocode is not a programming language, and it is a simple way of describing a set of instructions, and also it is not having a specific syntax to write a pseudocode. And in the right side you can see the flowchart for adding two numbers. Flowcharts are the diagrammatic representation of the algorithm. We will study about the algorithm development in the next lesson. Now just get a brief idea about that. And the next step, step 4, is test the algorithm for correctness. After developing the algorithm to a solution, you must check it for drawbacks and the problems. If we have some errors in the algorithm or algorithm doesn't give the correct answer, after building the whole program, it will give wrong answers or it will not work properly. So this is the simple and best stage for check the errors and test the algorithm. Testing is the process of checking the algorithm and removing any possible errors. Normally we are checking algorithms by use of disk check table, and also we are calling it as hand tracking. Disk check table means it is an informal manual process for verifying the programming and the logic of an algorithm. If the algorithm has errors, we have to correct them. Otherwise, we can move to the next step. Next step is coding. Code the algorithm. In here, we are converting the algorithm into actual computer program. For that, we can use any programming language to implement the algorithm that created using pseudocode or flowchart. Then we can run the program. This involves the actual execution of the program. When we are trying to run the program, again errors can be occurred. That can be logical errors, syntax errors or semantic errors. If so, we need to find the root cause and have to solve that one, and again build, and we have to run the program again. And the final step is documentation and maintain. If the program is successful, we need to create a complete documentation for it. Documentation must contain details produced at all stages of the program development life cycle. Even this is the last stage, documentation must be done parallel and ongoing from the first stage of the program development. That is the easiest way to complete the documentation and development of the program successfully. Now we will see an example of designing a simple algorithm. You have a work to do in this week. I will explain the problem and create a defining diagram. You have to try to write the algorithm for this problem. Then the problem is calculate the multiplication of two values. Normally, when you are doing multiplication of the two numbers, you get the two inputs and processing by the brain, and you give the output to the user. Same way in the algorithm. First you should take two numbers, then you should multiply those, and finally the results must be displayed. Here I have created the defining diagram. First we have to identify the two inputs. That two numbers we have to multiply. As the next step, we have to identify the process that we want to do. First we have to read the two numbers, then calculate the multiplication and display the multiplication. We have to identify the output. The output is multiplication. Now the defining diagram has been developed. You have to try to develop the algorithm now. I will explain the algorithm and the more deeper in the algorithm development in the next lecture. And I have uploaded a simple worksheet to your LMS with these slides. Try to do that. If you have any question, you can email me. I have given my email address in the first slide. Thank you.